focus more on scripting side, being the programming aspect of prototyping, especially in Unity 3D using C#. Just to make sure, I've been told that wasn't broadcasting before. So I'll start once I'm confirmed that we are live and there are no issues. Yay, it's working now. Welcome back, guys. I will jump back and start over the things I have covered, which wasn't broadcasting. So once again, my name is Noman and I'm online campus programming teacher, and today we'll be looking at live workshop for prototyping in Unity 3D, and we look at the programming aspect, the scripting aspect of game mechanics, how to build a quick game mechanic in Unity 3D. So I'll just quickly jump to over scene 2 for Unity 3D. This is set up. Small objects are there, some objects are there, but I'm going to delete them to start over because it wasn't broadcasting before. I'm going to delete everything. So we are on the same page from very start. Alright, so basically the idea is, before I start the mechanic, I want to demonstrate today is a sphere which I call blob. It just moves around with physics component like natural ball rolling around, and there are other objects around. For this, for demonstration purposes, I'm just calling them soldiers. And so basically, when the blob hits the soldier, it destroys the soldiers or engulfs that object, and the blob size will increase by each hit to the object or to the soldier. So that's a simple mechanics to demonstrate that you can create mechanics like these. You think of an idea, you do brainstorming session, or you've been requested by your team, or for fun. So there are many visualization of creating quick mechanics and the beauty of programming for Unity 3D. So let's start. First thing we're gonna create is sphere, which is our character or play character or blob. Other thing, we'll need a surface. Let's create a plane. Just to make sure sounds good now. Okay, here we go. Surface. Right. So our blob is there. Surface is there. Okay. So at the moment we run, nothing happens. Okay. So we have to create some scripts. So first thing first, we need a scripts folder. So we keep everything organized. I'll also use Prefabs folder. Which we will look into prefabs shortly, but first I'll create a C# script. I'm gonna call it blob move, and straight to MonoDevelop, which is the default editor for a Unity 3D. You can also integrate it Visual Studio, the latest version 2013, 15, if you're using that. Back to our blob move. So we have to, what we need is, we need speed factor. We need the scale factor. As I said, we're gonna scale up as we hit the other objects, and also we look into another script, which will be the soldier script. So what do we need first? First we need is the blob movement, and how we're gonna do it? By keyboard inputs. First thing first, So if input dot function we'll be using is getKey, because it provides you with the key code, and I prefer to use key codes rather than typing input keys, which you can set up in project settings that you can name them as fire or jump, and you can use the strings to match and get the input accordingly. You have to uh, reference the key names with the keys. If you prefer that way, that's fine, but I myself like key codes. So if key code dot up arrow is pressed, then I want to do something to our blob move around. So as I said, it'll be a rigid body, or as if for physics simulation, I'm going to create it as a rigid body. Back to our Unity, to our blob, I'm going to add a component rigid body. Okay, as you saw, it's actually was playing, and while playing you add the components, it will erase the changes made while the game is running. So I'm going to add the rigid body again, and in our script I will declare a rigid body variable to get the reference of the game object. So I'll do something like private rigid body and our body. Okay, so in start I want to get the reference of object's rigid body component. So what I'm going to do it is this dot get component rigid body, and basically what it says is because start is a default functions, once you create a mono behavior script, it gets generated, automatically generated start and update. There are other functions as well you can use, such as awake and fixed update and whatnot, but for start is when it loads the script. This is the first function gets called, other function gets called is awake. But in start we're going to get the reference for our rigid body object, so we can manipulate or play around with the properties of our rigid body. So once we give the key inputs, so we can add different forces to our object because it's a rigid body. So that's why I stop in my update function, and now I'm gonna change or update for my key inputs. So if up arrow is pressed, what I want to do is to my rigid body, to my rigid body component dot add force. I want to add force because I'm pressing up key. I'm gonna add force using vector 3 because force is added in 3D space using vectors, and also the reference of Unity3D. And what I'm going to do is going to ask it to forward. Okay, that said, there is still something missing. That is the speed, how much force we want to add in. So we're going to add a scalar factor. That would be our speed. I'm going to put it as public because when we declare a public variable, it can be edited from our Unity inspector. So if you're testing around with different attributes of a script, you can do it while you're playing the game to test it and adjust it as you go. And this is very powerful for testing your different factors you want to test. I could have done, I'll just show you, I could have done other way rather than making a public variable. I could have done into 10.0 which is of course a bad practice, because if you're not happy with your calculation is not right to speed, then what you have to do is you have to keep coming back to your script and keep changing that value, and you won't be able to debug as we do it with our public variables. So that's very important point. So what I'm going to do here is just going to add our speed constant. So what do we need else? So we have up arrow means move forward. That's I'm adding force to vector 3 forward and to our vector. But we also need for backwards, left and right. So what we're going to do quickly is just copy this, then gonna add the back arrow, down arrow, sorry, and dot back. Vector dot back says add force to its current orientation backwards. So you don't have to worry about direction and all that. That's the beauty of the rigid body. You're just adding the force, it gets calculated, and it will be animated. Same thing for our left and right. Before that, we just make sure we get the left arrow. Okay, as I said, for question answer, I'll be answering once I'm finished with my demonstration. It'll be easier to focus on your question and I can relate to it. I've been told that there is a question from Lucas. I will get to that once I'm finished demonstration. Okay, so we're getting the key code dot left arrow, and we want to add force to our left. Same formula, nothing special. Finally, for our right, that's it. We are done with our scripting, but how do we know it's working? We're just gonna save it. Going back to our Unity. But do we have that rigid body? Yes, we do. Rigid body is there. Okay. We're gonna apply this blob move script to our blob component. So you can do it in many ways. Just drag and drop onto it, or you can add here, or you can press add component and find your script from here. So you're just adding your script. So see how I had speed a public variable. It is as soon as I apply the script, it's there and I can see the default value of it as well. So let's see what it does. We don't have any errors. Usually the console shows all the errors and warnings. Okay, here is our blob. Let's just fix some camera. Select the camera. Press E for quick rotation. 1, 2 if you're happy with it. W for your moving. movement of the game object you have selected. While I'm doing it, while I'm running the game, I have to redo the changes in the scene. Let's see if I press up key, left key, right key. This is very smooth animation, but as it's adding force, so ball is rolling as it goes forward, backwards, and like that. So our simple first mechanics of ball movement is, or blob movement is working fine. We applied a rigid body component to it, just applying different factors to different forces in different directions. So of course, these are important concepts to understand before you get to create crazy stuff. So this is very simple stuff. So let's see what else we can do. Yay! All gone off the screen. So of course we are back. Now, yes, we can add terrains as well. Of course, why not? But to keep it simple, we're just sticking to it. Next thing is we're gonna create a soldier, or you can call it whatever you like, object. Just gonna create a cube. See, this is no shiny stuff, nothing, no, we don't have any textures going on, pretty blank, because the whole purpose of it is to just test the mechanics. So cut down all the noise, which is not related to you as a programmer. So you completely focused on getting things right for your mechanics. So all you need is the simple objects, because logic is hidden there. Once that logic works fine, like the blob move, you can replace this with something else. If you want to add texture to your blob, this is fair. Or if you want to add different shader effects to it, you can do it. But the whole purpose is to keep them separate, to get the mechanics right, and then on top of that, having the iterative additions to your prototype, or if you want to integrate or implement into your main gameplay for your game. So alright, so let's rename our soldier. Okay, for that we'll be creating it as a prefab, but first we have to make it work for one object. And the idea of prefabs is, once that object is working fine, you can just duplicate it, and you'll just make the change to the source prefab. That's it. It will be duplicated to all the instances of that prefab. Okay, so we need another script. Oh, it's called script. Might as well call it soldier. But I'll be deleting it, because once you name it, the class name gets created with it as well. Let's see, what do we get? See, it's called script. Even though I renamed it, what you have to do is, you have to make sure the name of the file and the name of the class is the same. Otherwise, it won't work. All right, so we are here for our soldier. So because we want to make our blob collide with these objects, and we want to have something happen. For example, we have to update the score, make our blob grow bigger, all these factors. And for that, I'll just update our blob move shortly. But before that, let's write some code for our soldier script. Okay, so what do we need for collision detection is we need the reference for our rigid body, which is blob move, and of course this is rigid body as well. So what we're gonna do here is first we'll get the reference for our blob move script, because we also have the public variables defined there. So if we want to access those variables, so we have a local object which we can get in through our get component method, and we can access those properties. Very interesting, powerful, and important. So we have our blob move. Of course, we need the game object reference of its own, and the blob game objects, how they're gonna interact. So we have mblob game object. We'll update the score later. So first thing we need to get is mblob. Once this script gets executed, first thing we need to do any calculation. Before any calculation, we need to get the references right for our game objects. So we call game object G capital game object dot find. Simple function. We just gonna call the name of the object. So that's where you have to make sure you are typing in the right name in it. So of course, to make sure, we jump back, blob, sure. You can do all kind of crazy stuff such as try catch statement to make sure if that object is not there. So do things otherwise, or prompt that this asset is missing. Especially for development purposes, this is good practice for debugging things and catching the horrors of programming. Second thing is we need the reference for our script. Okay, so what component we'll be looking at? And blob move. And the good thing is for IntelliSense, for MonoDevelop and the Visual Studio, it suggests you with the right references. Okay, so we got the game object and the script. So far so good. So because it's a rigid body, so there when you apply it to apply a rigid body component, so you can access on collision enter, on collision stay, on collision exit, because this gives you the ability to control the collision detection. Very powerful. So in programming, we straight away we can do things like void. Of course, you have to have the right signature for your. Okay, heads up, we are already 30 minutes in. I'll try to go a bit faster so I can get to the questions. The signature for this function is on collision enter, type collision. You can call it collision with small c. First thing we want to do is to destroy this, because when blob hits the soldier or the object, it gets destroyed. So we're gonna call it a small g. So basically destroy this object the script is applied to. Also, I like to use functions like print just to make sure, especially at the debug time, it's a good habit to keep a check if it gets called properly on this collision, especially event functions. So you can check it on your console that, okay, this, because it's an event function, it's getting called, and you can see the results on your console. So simple, something like that. Other thing we have to do is for our collision, once we collided with our blob, we have to update our blob. So I'm gonna create a method for blob update. So we have to update blob as well, as we have the reference for its game object and the component itself. You just need the game object. You can get the components as you go, but I like to keep them separate so I can play with the game object separately and get its component as a local copy, so it doesn't create some mess. So what you have to do is, as I said, when the collision should happen and the blob should uh, get a scale up. So let's do that, and blob dot, of course it's a transformation dot local scale equals to, we're gonna update it, so we say new vector 3 what, and blob dot transform dot local scale, what its actual scale is, because it's increasing all the time with the relative to what its scale was before this hit. Dot x plus, again we're going to use a constant, so you can say blob, which we haven't declared yet, so we can say float blob scale 1f. So we use IntelliSense. We're just going to add the factor for blob scale. Of course, we have to do it for x, y, and z. So I'm just going to copy and paste for x, y, and z. Y vector, z vector, and that's it. All I have to change is y dot z. Okay, this should scale up the blob once it's hit. Okay, also other thing is, because it's a rigid body, I have to take care of its mass as well. Again, this is something needs to be understood before we go on all guns and blazes playing with rigid bodies and applying all kind of physics. So we get component dot rigid body. I'm just gonna fix its mass, because even the size increasing just make it equals to, okay, just rushing a bit because I've been told already some time has been passed. So 3.0f, so it will keep the mass on 3.0f even the scale is going up. And also the other thing is angular drag. These are the properties you can see once you apply rigid body component to a game object. So angular drag equal to 0.0f. Okay, I'm not updating the score, but let's see what it has so far for us. Any updates? There are warnings. Okay, It says soldier move is assigned but value is never used. Good. Okay, for now, I'm just gonna apply this script to our soldier. But we also have to apply rigid body because it's a rigid body in the way it's gonna work. Let's see. Okay. If we do the split, we can see what is happening. Where is our on collision inter? Because it is touching the surface of the plane, and on collision inter is just destroy its object. So what we have to do is just stop it for now. Let's say mesh collider, and both will go down. Okay, we can add terrain. And let's take our object. Okay, so we grab our objects, soldier and blob, and move them to somewhere. Yeah, so let's just fix a bit more. Let's play. Okay, our getting destroyed over on collision inter is getting destroyed on collision destroy game object is. Okay, I have to put it a bit. One thing we can do is not to add the rigid body component. Let's see what do we get. See, I had to remove the rigid body component to it. Now that soldier is destroyed, basically, I just put it back. Basically, what I was doing is adding the rigid body to our soldier as well, but I didn't have to because it was colliding with the terrain and was getting destroyed. So basic mechanics, what we have achieved is we created this simple mechanic, just simple, just moving the ball around. This is our soldier. Of course, this we're testing if it works fine or not, and bang, is gone. And we can do all kind of things once that collision happens. Just making sure we are not running out of time. 40 minutes, we still got a little bit of time. So before I jump on to question answer session, I'll do a little bit other changes. We jump onto quickly for our prefabs. So we got our soldier. We're gonna create a prefab. We can go create prefab. I'm just gonna drag it onto our prefab, and look, it's there. So now I can delete the original. And the good thing about that is because I have tested it, before I tested it, it was working fine. So all I had to do is to make sure that component with that game object is working fine. And of course it gets complex. Why we are adopting this approach is to test with one object, make sure everything is working fine, because once you have lots of objects, and of course if you have created some prototypes, demos, or you have just played games or just watching this demonstration, so once you have lots of component lots of game objects going on, and if your mechanic or core gameplay is not working right, so of course you're gonna waste lots of time to debug and do things like that. It still happens, unfortunately, but of course we have to adopt the best practices. So I'm gonna do is add some more soldiers so we can test the mechanics. It was simple, just ball rolling around and we test. And I can do copy paste. So we see, now we're going to check if the collision detection and all that update is working fine. Before we do that, I'm just going to make sure our camera angle is right, so we do see what's happening. The collision detection is happening properly. Okay, we can do maximize while play. Let's see. Yay, bang. And it has that feel of applying that rigid body component. It has that feel of when it hits, it the response, its response is like it should be, like a normal physics simulation. And that's it. All you have to do rest is we can add things like score and things like that. For that you would need user interface, so we can start with canvas and add panels to it, component, or you can add text. Of course text just gets displayed onto the game, so text is here. But it is important that we cover the mechanics, core mechanics. We can do all kind of updates. What you can do is here, when the collision is destroyed, so you can there was one thing wasn't happening. The blob wasn't actually scaling up, so that you will see now. I was like, okay, it's just a collision detection is happening, something is missing. So rather than doing the score update stuff, let's see. So here is, let's see, we can also increase. Okay, it's not scaling up for some reason. We'll just make sure if we have saved the script. Okay, I'll just make sure I finished my round. Alright, back to our scripts. Soldier, mass scale up, local scale. Just making sure if I'm not missing anything, so it's not just scaling up, but at least the movement and collision detection, and it's all responsive, and you can see how it's working fine. We're left with 15 minutes. If you guys have questions, feel free to ask. I'll just jump onto the questions very shortly. Okay, so we have public for 0.01f. We are adding that to our transform blob. Define blob local scale.x. All right, maybe we can cover it later on, but for now I'm ready to take your questions. So feel free to ask me questions about the demonstration, what I've done, created things. All right, before that, just one thing I want to add as a good practice. For our scripts, as we were working with the component which is required for our script to work with our blob and soldier, basically it was the center point. The component was must have. So what you can do that to ensure if that component gets added to your script, I'm gonna open up our blob script again. So of course, the first thing we are doing here, we are adding our rigid body, right? And if rigid body is not there, let's see what happens if we delete it. So I added it before. Script is still there, but what's happening here now? What will happen? Let's play. Nothing. And you'll see missing component exception problem. So how to make sure that doesn't happen, that your script ensures that component gets added to your game object. So for that, we use something called attributes, and the attribute we will be using for this script is required component, which enforces to add the required component. So the way we use it, type of basically predefine objects such as rigid body. Let's see what it does to our script. Nothing happened. Make sure it's there. Okay, gonna remove it, remove the component. I'm just gonna add the component again. Look, as soon as I added, I didn't add rigid body, I just added blob move. Rigid body gets added automatically because of that attribute we used. And there you go. So you're secure to use rigid body, but using one attribute, you are free of that problem which we had. Okay, I forgot to add one component. So if it's a requirement, of course, you can add attributes like that. Of course, the complete list is on Unity3D, and all the concept, of course, you have to learn before implementing all these concepts. I think it's good time. We're left with 10 minutes. Thank you very much, guys, listening. And now let's see what questions we have. All right, Mick, if you can help me get these questions. First one, you from Lucas, for terrain, would I make just a basic rectangle? Yes, for testing, yes. As I've answered while I was doing the demonstration, I've actually deleted the plane because it had a mesh collider in it. I just added the terrain, and of course for terrain you can add all kind of crazy stuff. So of course That's more of a design thing. Of course, that's level design. You can, if you want to test a different environment, you can add. What's my thoughts on rigid body and character controllers? Uh, Rigid body and character controllers, you will you can use character controllers, but character controllers you can have, for example, in the scenario, if I would say, for example, first person setup or a third person setup, and that it uh, gives you some default settings set up for you. And for rigid body simulations like these, which they don't have to work as a character, yeah, there are some settings are missing. We are basically create a character controller out of rigid body. Character controller itself is a specialized rigid body. So I hope I answered the question for Mickey K. Okay, I'm just looking at the questions now. What did you thought on rigid body? Character controls, yes, answered that. Can make it really easy. A lot of typing. I think this is a lot of typing. You are in for a shock if you want to study AI. Assuming you want to do programming. Of course, for programming, okay, no worries. So if there are no questions, I'll wrap it up. All right, guys, thank you very much for listening. Hope this helped you a little bit. And yeah, good luck with your programming, prototyping, testing your mechanics. Your comments, feedback is welcome. Thank you very much.